Okay. I'm thinking that I'm going slowly enough. We may not look at this video here. You could look it up later if you want, or if it's just a 2-minute video from Climate Reality. Who wants me to try to see it? Okay, well, let's see how technically competent we can be here. Well, heck.
Dear Stephen Harper.
Dear President Jacob Zuma.
Dear Prime Minister Narendra Modi.
Dear world leaders.
We all know that the climate crisis is here.
We can see it all around us.
We are all affected by it.
और अगर ये हमारे
Dear Stephen Harper.
Dear President Jacob Zuma.
Dear Prime Minister Narendra Modi.
Dear world leaders.
We all know that the climate crisis is here.
We can see it all around us.
We are all affected by it.
और अगर ये हमारे ऊपर होता तो
We would do something about it.
In fact, some of us already are.
In our businesses.
Now it's your turn.
As our leaders.
As the ones bestowed with power.
The power to represent the people.
To represent me and me. And me.
And me.
And all three of us.
Don't forget me.
Please listen.
Listen to the land.
Listen to the ocean.
Listen to the science.
This is summer 2015.
You will be right here in Paris.
At the UN Climate Change Conference.
माँ की कुछ अनुरोध है, माँ की कुछ विनती है.
Actually, we have some demands.
We demand that you cooperate with one another.
We demand that you send a message to polluters.
Stop using fossil fuels.
Now is the time.
The time for you to act.
You need to make long-term commitments.
Commitments to reduce greenhouse gas emissions.
And when you do,
The world will be a better place instantly.
I want you to look after my future.
A lot's riding on what you decide.
Thanks for listening.
Pretty great, huh? So, yeah, thank you for wanting to see that. Let's see. So that was our video. Any comments on that? I was a little busy getting ready for today, but I am going to go sign that petition after class. And that leads us into what I think, you know, a Dickens moment, right? The best of times and the worst of times. It really is the best of times, I think. What has come clear to me just in the course of this quarter is all the news that I've been hearing from our speakers, from GSEP, from the headlines, that the world has gotten it. A lot of the world has gotten it, enough of the world to make some changes. And that I love, this was something that Amory Lovins was saying in his talk. You know, as I say, I've been reviewing those the last couple of days too. We have billions of people who care, connected by billions of cell phones. The world's a little different. You know, the people who just spoke to you have, like us, have more power, have more ability to try to get us going in the right direction. And this stunned me. I've now heard it 3 or 4 times in big meetings this quarter, besides just what you read. New renewable energy installations, even in the US, which has been a little slow to get this, have been outnumbering fossil-based systems. Fossilized, I decided to be a wise guy there, have outnumbered that. That we have hit a turning point, and it's been, in large measure, about the economics. You know, it hasn't been just because, you know, people finally listened to folks who were demonstrating or anything. No, it's been because people the technology's gotten there, the flexibility's gotten there, and the people who make these economic decisions have said, this is right. I have a thing we probably won't have time to go to that my husband found, Phil Barth, who found this BlackRock investing brochure online that talks all about why you should be investing in sustainability. And it's like, wow. And it's serious, right? It's serious for people about that. Another, I think, good news, and you've heard I really enjoyed my time at Chevron, but the truth has come out about past lies, right? About Exxon's big lie. And people are understanding where some of the naysaying has come, some of the just ludicrous denial of reality has come from, which allows us to go ahead, right? And 122 countries out of the 140 some odd already made commitments before coming to this meeting, to the COP21 meeting in Paris going on right now. Already made commitments. They may not be enough. People are certainly worried, myself included, that these commitments may not be enough to avert great harm, but they've been made. It's better than not. So as Alessandra is telling us, behind the scenes, people are furiously working to try to make things actually work out, to make the right decisions, to make the decisions that countries can live with and live up to. But wow. And here's a big mix of the best of times, worst of times, right? Here's the photo that Doug decided to share with me. This is all the shoes, right, or some of the shoes that people left because Paris, of course, is under siege. They're under a state of emergency still from the bombings, the recent bombings. But in lieu of being allowed to march, people left thousands of shoes to march for them, I guess. And what a typically beautiful, in a Parisian way, photo that is as well. People are speaking. But it's the worst of times, too, right? I mean, it's not like we can just go home and have a beer and say, wow, that was a close call, but it's all okay. No. There's a heck of a lot of work to do. The thing that the best of times is telling us is that we'll be able to do it, right? The environment is going to allow us, I think, to make the changes we need to make. So it's difficult to see how we could possibly stay within the 2-degree limit that people have agreed. Beyond the 2-degree limit, we have some really horrible consequences, right? It's hard to see how we're going to stay below that. In fact, I think the predictions tend to be around 2.7. And that's going to have huge disruptions. And with that comes rising sea levels, violent storms, extinctions, drought, wildfires, temperature rise, climate refugee situations. All of that is going to get worse before it gets better. I'm convinced that's true. But I am really amazed, 6 years ago, 10 years ago, when I guess it was 2006 when I got really concerned after having seen the Inconvenient Truth movie, I concluded, well, solar energy would be great to get into with my skill set, but there's no way it's going to make an impact in time. And I was wrong. I mean, lots and lots of people didn't think it could possibly be making an impact in time, but it's making an impact already. So perhaps the world will surprise us here. Maybe it's not going to get quite as bad as we think, but I am convinced it's going to take many, many of us, the best and brightest, doing a lot of dogged work to fend off as bad as it could get. So here we are back to the MIT greenhouse gamble. I know I showed you at the beginning, and back in 2006, this was the prediction of what the probabilities were that we could stay, within a certain temperature limit. And by the time this is what it's at now, just a few years later, it was to this, meaning that by their estimate, there's almost no chance that we're going to stay below 3-degree temperature rise C. And what does that mean to us? I know I showed you this too, but I was really struck by a couple of summaries students wrote, just how big an impact it was on you, so it seems worth saying again, that it makes a large difference whether we stay below 1 degree or 2 degree or 3-degree C rise. It isn't that, well, if the temperature rises at all, we're doomed and that's it and give up. Or if we stay below, if we stop rising, stop emitting now, we're okay. No, the consequences get progressively far worse the more we let this get out of hand. So the action, people who are worried, well, maybe the COP agreements aren't going to be good enough. They're going to still let us get up to 2.7 degrees and maybe more. Those are valid worries that really make sense to think about. I showed you this on the first time. I'm not going to do it again, but if you come back in the site or want to look at this, you can. It just shows you, it's a good way to help answer deniers, if there are still any left that you know, what it is that's actually warming the planet. And you can add it piece by piece. The IPCC, also, as I showed you at that point, is showing you CO2 on the rise, Arctic summer ice diminishing. You know the story. I'm including this just mainly in case somebody online is watching this and wants a little bit of context, right? The projections of what our sea level rise are pretty dire. And there's our good old denial, right? And rising sea levels, and a reminder, there is no CO2 techno-fix, right? There's no easy way that we're seeing to get CO2 out of the air now. Now, we've had some interesting talks about ways that might, but they're not ready yet. It's a good thing to work on, but they're not ready yet. The acidification is a problem too. One of those links that I gave you a few slides ago of Brent Constance's talk a year or two ago is another interesting way to try to use CO2. The jet stream is still destabilized. We still have severe storms. We still have horrible extinction rate happening. We've just begun into the 6th wave of extinctions, and it's serious. But here we are, the entrepreneurs, the technologists, the people who made the financial decisions to bring in better energy sources have really done amazing work so that things are better than we think, and the forecast did underestimate the possibilities for change. So it's all coming true. And this is the big thing I learned this quarter. I mean, this is headline news. How much better solar cell efficiencies have become, how much more it's been adopted. And the wedge, somebody was also in their summary talking about, define where we have to get and then wedge by wedge approach it. Yes. I know I showed you this too, the Earth's energy balance. And what ICE 911 does, what Geo Engineering approaches in general do, is they start looking at how can we reflect or deal with some of the radiation in particular. Of course, let's invent it. If the YouTube people are kind, what I want to say is we've had some interesting talk here, especially Kimberly Weefling, about how you really design what a person needs, rather than, go for the glamorous techno fix you think would be intellectually satisfying to do, or fixing a problem without diving in. And this is one that really got it. And if it will come up for us, that would be good. Oh, come on. What? Really? Really? Okay, fine. This is why we never assume. Let me tell you what this would show you. I had the honor to be in a brainstorming session at Summit Public School, which is a really good charter school near here, where they had Dr. Frederick Furt, who was the global program manager for innovation and creativity at Google. Can you imagine that? It's like, let me come to this session. I mean, that was just pretty great. And this is one of the things he showed us. And what this is in, I'm not sure it's in the Philippines, it might have been. There were these communities that were living in basically, it was certainly not a rich area, living basically in shipping container type houses, metal boxes pretty much. And within these, they had no light in the daytime. So they'd go inside, and there's nothing they could do in there. They'd trip over each other, So you're living basically outside when it's light, and you're going in there only for shelter at night. So you need light, right? But light takes money. It takes energy. It's hard to get. And what this guy did was he went around with a little saw, and he'd saw a circle out in the roof, and he would fill basically a Calistoga bottle full of water and a little bit of bleach, I guess, so it didn't get mold. And he'd put that in, and he'd seal it up so it wouldn't leak in the rain. And when the sun shone, this reflects out, this just shines out through the bottle, lights up the whole house. It's like a miracle. So if you can find this video when somebody isn't complaining about copyright infringement, it's really a kind of humbling thing, you know. You can work on really complicated technologies, but if you know what people really need and you make a couple simple observations, you can have a profound effect on people. It will cost almost nothing. So that's one to keep in mind. So with that in mind, I had a rather simple idea. Are there any questions before we go into ICE 911, just in general about what we've covered? Okay. And I know we raced through some of this along with Geo Engineering and all kinds of things at the beginning of the quarter. But here we go, because you guys wanted to hear a bit more about this. So the thing that struck me when I got very concerned about climate back in 2006 was just like, wow, what can somebody with my background do? What on earth? And I finally came onto this ice albedo feedback effect, the thing that's making that 34-second video of doom that you saw at the beginning of the class happen, is that the faster, the more the ice melts, bright ice, the faster what's left will melt. Because in the meantime, the ocean's getting warmer, your area of ice is getting smaller, you're eroding not just from the sides, but from underneath. And if you squint at that the right way, that's a materials problem. And that's the way I decided to squint at it. So it's like, what on earth could I do to try to affect that would be a practical thing? And my thinking was, it's a backup plan. And some of you, actually our distance learner in particular, was asking, how do you even start something like this? I started it in my kitchen. I started it in my home office. I started it just walking around obsessing about this. It's like, what could it be? At that point, we had a huge daisy garden in our front yard. In fact, I think you gave us the first ones and they took over. White daisies, and you start thinking, would floating daisies on this do it? You know, what cheap material? Yeah, I was just thinking all kinds of crazy things. Maybe Calistoga bottles. We should have a cottage industry roping Calistoga bottles together, painting them white, and sending them up to the Arctic. Terrible material for this, by the way. But, you know, just thinking broadly about what on earth would help this situation. And so that's where this began. It was just thinking and web cruising, you know, in between consulting gigs, just what on earth could make this better? And I really thought this was the backup plan I hoped we would not need, but it was like, you know, if humanity does what humanity usually does, which is not take action until our backs are totally against the wall, then we're going to need some options in there. We're going to need some Band-Aids. Can we make an option that's going to be easy to undo, but practical to do in case we really need it, and characterize it in advance of need? And so it's as simple as floating. What I came to eventually was hollow glass spheres, and floating things like this in water was basically the summation of the concept. And it's you know, thinking of that plastic bottle light bulb, it's not that subtle an idea. But what's appealing about it is it's harmless, it's relatively cheap. Daisies, by the way, I thought, my gosh, daisies grow so well. What if we had daisies taking over the entire planet on every coastline of the world if these seeds got away? And I decided that was probably not a good plan. The vocabulary word here, I've been accused of never explaining this, is albedo, and that's basically reflectivity. So it's a scale that goes from 0 to 1. 1 is 100% of your light is bouncing back, 0 is none of it is. And basically open ocean absorbs about 95% of your sunlight, at least at normal incidence. You know, oblique, it changes a little. And ice reflects about 95%. So absorb about 95%, reflects about 95%. Why is this important? So many reasons, but one of them, the one that grabbed my attention first, was that back in 2006, they were saying that 20% of global temperature rise, so about a fifth of it, was due to the fact that now in the Arctic in the summer, while the sun is shining on the ice, or where the ice should be, more of it's shining on open ocean, so things are warming up more, so about 20% of global temperature rise was coming from us taking in more summer sunshine than we used to. And now, the last that I have heard, the estimates are more like about a third. So we've gone from 20 to 33% of temperature rise coming from this one effect. So it's a big effect. So if you're thinking about it and you want something that's going to be fast and removable if you need it to be, and you know that one person could make some kind of impact on in their spare time, that was the one I chose. It's like, wow, that would be a huge effect. So that's the idea. Yeah, right, 10% of the world's ocean area is in the Arctic and Antarctic. It's a big deal. So this 20% is out of date. This is an old slide, but it's worth showing. And this was, you know, the IPCC. Oh, I've scaled it without changing it, sorry. I tried to add from 2007 to 2012, but it was dire what happened there. Basically, that we're down to about 50% of the original area of the ice within just the last 3 decades. And we're down to about 25% of the volume. And it's far, far worse. Don't do that. It's far, far worse than the IPCC fourth assessment predicted, where the average of all that is the red line, the average of what they predicted, but what actually happened was worse than their worst prediction. And that's been a problem, right? When you get a lot of people trying to make a consensus report, you tend to want to avoid being labeled as an extremist, and you tend to get a consensus view that could be conservative. So that's what's gone there. So it's accelerated a lot faster. There's a nice write-up in Fast Company that came out about our work about a year ago that I liked. He puts this very, very coherently. So if you look this up, I think you can find it on our ICE 911 website. You can see this. I seem to be in some sort of time thing where it wants me to move along. And so what we did, you know, getting the advice of everybody I could get at Stanford and beyond who knew climate, because I know I'm a chemical and an electrical engineer specializing in MEMS, talk with all the climate guys and try to get some advice. I kept getting very positive feedback. Steve Schneider and Terry Root were the first climate experts I talked to. Armin Cohen heads up the Clean Air Task Force in Boston, was one who gave just a beautiful quote from this. He's part of our governing board now for ICE 911. You know, that this is important to try to address this, and nobody else was trying to address it. It's like, well, okay. You know, remember, I'm an inventor. I'm comfortable with kind of being out there. So that's what we've been doing. And so there it is in summary again, what we're trying to reduce. This, having blocked out all the buoys and things, this is where we were just as recently as 1980. A lot of bright reflective ice in June of 1980. By June of 2002, not so much. Actually, you know, let me be clear about this. What is really shown here, this is from some work by Ignatius Rigger and John Wallace at University of Washington. And what they were really looking at was age of sea ice. But the age corresponds very well to the brightness. And so when they made the scale of brightness in here, it's pretty convenient for us. Wow. I'm sorry about the timings here. And so what you can see is open ocean, very absorptive of sunlight. First year ice, you know, you've probably seen it. Glare ice, ice on a skating rink that's trying to be pure. Very transparent. But by the time you get to multi-year ice, it's had a chance to melt and reform numerous times, and it gets air pockets and liquid pockets. And this is what, and you've seen Doug Staub's pictures, right? All these lumps and bumps. This is what gets you brightness. This is what gets you high reflectivity. And this is what we need. Here's a handy place to say, that's as far as we got. We've done an experiment up in Barrow. That's that little pointy bit. And if Doug Staub gets his way to help us, one plan I have is to try to help the loss of ice that comes out here in the Fram Strait. And I think Svalbard is over there, and he's trying to get us in to work with the university there, because a lot of bad stuff is happening in Greenland. So this is where, as in standing water for 2 weeks, over 90+% of Greenland's area in the summer of 2012. And in 2012, here we are. I challenge you to find much bright ice left anymore in June, whereas just 3 decades before it was all over, right? I mean, here you are, boom, boom, boom. So that's what ICE 911 is trying to fight. How do you do that? Well, you take these bright materials, an even better material than the one that I'm passing around is a finer powder that you can also float on water. Although, yeah, costs versus how they're performing, it's all a pretty big balance here. Oh, would you stop this? But the idea is that you've seen as it floats around, you can float it on water, but it may be less complicated in deployment and politics to put it on ice itself, on thin ice, so that you know where it is. You can fence it in a little bit easier, and you can show people, you know, we're going to contain it here. That's probably a little safer while we're making sure there's no untoward impacts on anything, and it's probably politically a lot easier. So this is the idea. You take some area, you could float it on the water, you could float it on the nearby ice, you could perhaps slow down the melt on glaciers themselves, on places like Greenland, where you get these big areas of pooled water that get heavier and heavier and finally crack through the ice below and lubricate the slide of a big sheet into the ocean, and you can just keep things cooler. We've known from the beginning that doing this helps you keep water cooler. It was part of the aim. And now, as you'll see in a couple minutes, we're looking at this to try to help with California's drought as well. It has other applications. It may be helpful for snow preservation, although one of the things that we've noticed over time is that snow is very bright. So if you put this on snow, yes, you can conserve snow, but the impact, if you get anything that's a little bit darker than this, I guess this works really well actually. If you get anything that's a little darker than this, like what I'm sending around right now, you actually are behind the game. Because if it's darker than snow, it's going to melt its way in. So there's a number of materials that are cheaper than this that would be very, very tempting, but their albedo isn't quite high enough to help on snow. But on young ice, it could be very helpful. On open water could be very helpful. So, yeah. We'll get there.
You and I talked about those.
Yep, we did.
Yeah, so what are some of those?
We'll get to it.
What?
We'll get to it.
Okay.
There is a slide on that. I went through the Cleantech Open. ICE 911 was the first nonprofit, the Cleantech Open, ever solicited or accepted. And that's interesting because the Cleantech Open is all about building profitable businesses from your cleantech ideas. And this one is rather unrepentantly, no, we're saving the Arctic. And you run into this whole tragedy of the commons issue where who is going, it's for everybody, so why should my country pay? Why should I pay? And so for years I was saying, you know, we'll get to the for-profit things later, but the ice is urgent. Let's get that developed first. And I have finally come to my senses, David. And there's a for-profit application that we're pursuing as well. But I think it was very important to get this going. The important thing when you're doing something like this, and if you remember Terry Root's, you can look back at Terry Root's lecture from a year or two ago, which was brilliant, or look at the slides that I showed in the first lecture of hers. There's always these unintended consequences. When humanity does anything that seems even dirt simple, you know, we're going to introduce, I don't know, wolves to take care of the overpopulation of deer or whatever. You end up with these cycles of things you think you understand, and suddenly there's this unintended consequence, and it's horrible. And so I've been just adamant from the beginning, make sure that what we do, we can undo. I think if you're ever going to muck on things, you know, try to alter things on a large scale, you've just got to live with first do no harm and be able to undo what you're doing, because there will be side effects. I don't know what they are yet, but there will be. And if you decide the side effects are worse than the cure, you've got to be able to undo it. So that's been one of the things that I think we've contributed to the conversation. And that, you know, I keep showing you that fragile bubble that is the earth of what will you carefully try. That's where I live from. Of course, doing nothing is a bad option. And when people say, what's the eco impact of putting this material out there? It's like, okay, there will be some, surely. We don't see much, but there'll certainly be something. But what's the eco impact of having the ice disappear? You know, it's, we've seen this, I'm sure. We talked quite a bit in week 1 about geoengineering options, and this is a kind of geoengineering. But because we're so adamant about this, this kind of technique is being called soft geoengineering, or Steve Schneider labeled it eco-engineering. And the thing that I like about this is there's a prayer you can do it and undo it. You know, imagine if we succeeded beyond our wildest dreams and we drove the world into the next ice age. Is that good? When I was a kid, that's what we thought was coming. This was a nice ice age. So let's say this is temperature and we've overcorrected it. I think we're okay on this, though, because we are very, very good at soot. So I think we can undo that. And what I would love would be if the arguments down the road become, where should we make that set point of just right? Why, given all the good news that I've been saying of, you know, this is the best of times, people are getting it, we're getting renewable energy options, why do I still spend my nights and weekends on this? And that the answer to that is, I think we're still not going to get there fast enough to not have some great harms. And if we can slow those great harms by doing things like this, I think it's still worth doing. So that's why I'm still at it. How we've done this, we've done, well, this too is an old slide. We've done at least 7 years of field testing now. This is a pond in Minnesota that we know and love. And there's Tony, whose pond it is. And we put various materials out there, and we've been testing. First, little 5-foot squares. Actually, before this, I was testing up in the Sierra. You ask, how do you get something like this going? In the Sierra, I would just hop in my car, you know, before sunrise. I would bomb up there and see on the lake where we'd gotten permission to test. How did it look before sunrise? I'd take manual measurements. I'd do that. I'd adjust whatever I needed, and I'd come back down, and I would have sacrificed one day that week to this cause. If you're willing to volunteer and you make sure what you're doing is inexpensive, you don't really, you know, all you need is permission to work there. After a while, though, if you want to scale up, you've got to start getting some funding. Fortunately, I've had people who have made donations. We're now a 501c3, and we get instrumentation and travel covered to do this. We're in the middle of another fundraising thing. Oh, and this is my time. I didn't make a slide. If anybody wants to come to a fundraiser, we've got one a week from tomorrow. So Wednesday night at the Ladera Community Church, 7 p.m. And that will be helpful and hopefully get our end-of-year fundraising done for the next adventures. So here are some of the things we've done on this Minnesota pond the last couple years, and in fact this year again. Been out there a few weeks ago segmenting the pond with Tony and getting ready to put our materials out there. Trying to bury our thermocouples this year before the freeze, but instrumentation was complicated. And the problems of working with a mostly volunteer team persist. Nobody has time to get it really solid before it's, you know, before the freeze comes, for instance. So there's challenges. This year we really need to move the funding up to where we can have some really regular full-time people. That's a big aim, because the world actually does need this. We've done tons and tons of experiments here. This was the 2013 version. Here we are in the 2015 doing some more. And we keep finding just phenomenal results. Sorting out. Here's one where that material I showed you that isn't quite as bright as snow, you know, it actually drills its way into the ice. But the very bright stuff, as you go through freeze-thaw cycles, keeps percolating to the top because it floats. It actually turns out to be great. This was a year ago, 2 years ago, in a segmented way that isolated it from the whole rest of the pond. And we ended up finding that we had lots of ice left after ice had melted everywhere else under this particular material. We also got to Barrow, Alaska this year. You know, here's one of the great things about sacrificing your time to something like this. You get to go on some whopping adventures. And getting to be on the back of sleds with Eskimo whaling captain and his crew, was really pretty neat. I must say, as I'm clinging on to this thing and we're flying through, and I've got my balaclava on because I'm freezing, and they've got their jackets unzipped because, you know, it's not as cold as it had been. You're like, I'm alive. It's great fun. Kate, you must have this fun too, right? Yeah, it's just, but the logistics were difficult here. And so we found, you know, things were tough. Getting the Wi-Fi signal where they thought there was one, getting the right GPS coordinates, it was complicated. We got some very interesting images, but in shifting things the way that we needed to, we're not sure which came from which material. We know this family of materials certainly helps, but it ended up being qualitative more than quantitative. And for this season, at least, we're back in Minnesota. We may gear up and go back to Barrow. It was a really good experience, but, you know, again, limited funding, you have to make these decisions. This was very interesting, what Satish, the instrumentation volunteer from Forever, did, of having beautiful boxes for the cameras and for the albedo sensors. What's our wide area deployment cost estimate? Because that's one of the key questions everybody always asks. It turns out that it's our bigger, I forgot to update that particular line too, ignore that line. It turns out that our best performing material is actually more expensive than what I used to be estimating with. But we've got years of data now, so we can see that. And so now the cost of saving something like a 50,000 square kilometer chunk, which is huge. It used to be the historic summer to summer ice melt back in the 90s. Lately, we've been melting twice as much as that. Sorry, 20 times as much as that. Nonetheless, it's a good size to think of, and it's a size to make a reasonable plug between Greenland and Svalbard, the Fram Strait. That would be a reasonable plug. Comes out to something like $1 billion if you, sorry, $11 billion if you want to get that size covered. It might be worth doing. But that's the sort of thing we're doing, is getting, what are the basics here? Do we decide we want to do that? When you're thinking that every coastal city in the world is starting to spend things on the order of $1 billion to $10 billion per year to shore up their basic infrastructure against sea level rise, this might be worthwhile, right? And the idea is that you could rebuild. If you can reboot, if you can slow down the ice loss from the Arctic and let it reboot itself naturally by just giving it a little bit of a boost, the idea is you just need to nudge it for a little while. So for a few years, that's the thought. Here's where we've experimented so far. Alaska, 1 year in Canada working with an ice expert, couple spots in California, Minnesota, probably going on to Maine soon. So, the Cleantech Open, again, this is an old slide. We were the first nonprofit. We became semifinalists in 2013. We became finalists in Sustainable Silicon Valley 2014. It's about what we need. It's $3 million, $5 million would get us a long, long way. We could get this established. Cleantech Open, we had a really good mentoring group, one of whom had us sort out exactly what David was asking about. What is it we're trying to do? My focus has historically been on this, what we call public uses. The things for which we're not sure there's any particular person who's going to pay, but they affect the whole world. So this is the idealist here, working on this because, man, it matters. You know, when the sea ice is gone, sea levels, storms, it's just going to be bad. The commercial uses we've had in mind all along, here's a couple of the prime ones. I kind of axed out some of the others. And what's nice about these is they're practical and they're something that people would really want to pay for. And especially since California has been so obliging as to have this horrific drought for the last few years, we've started working seriously on that. One of your co-auditors, who isn't here right now because of a consulting deadline, Alex, has been helping a ton in ICE 911, doing some really good measurements on water conservation. And we were swarmed at the most recent Cleantech Open event, where alumni got to exhibit and we got to show our data and how good this is. And people are really interested. Cleantech Open is interested in for-profit solutions, and this is one. As I've said, we've known for years that what we do cools things. And so it turns out if you start deliberately measuring that for drought applications, people do get interested. It's actually a win. I've maybe been a little slow to pick up on this because of limited time and really knowing how important the ice is. But it's really a win in that when, not if, when we get the right permitting and connections to work on a fairly large-sized lake to look at this, probably in California. Minnesota isn't the right climate for it, we've asked, but probably in a spot in California, and get to experiment with this and show how safe the materials are and affordable and reasonable. This then will help the acceptance and the development of the materials to let us go ahead and save the Arctic as well. And so we've been using that, slightly different team mentioned here, same good quote, same sort of picture. But what we've been aiming for is just this horrible need we have in California's reservoirs and lakes. And why is this an advantage? And you all know this, right? We've been living it. Why is this good? There's a couple things that are really a nice feature about this. The infrastructure, as you're trying to build a reverse osmosis plant or a reservoir, it takes a long time. It takes billions of dollars to get these built. What we're doing is we're going ahead and just saying, we've got materials. Sometimes I should grab that. Sometimes we can make pancakes out of them if we want, which is a little more work. Here's teeny prototype pancakes. But imagine making pancakes that are large enough that you can now suspend these from a deliberate spot in your reservoir. And it can just stay there. And nobody's worried about whether fish might eat this, right? Sure, enjoy. Yeah, they're safe. That's the point, really. This is something that we think is pretty exciting. And there's Alex working away on, come on, let me stay there. Working away on various wading pools that we have out in the parking lot of our consulting company to measure how much better are we doing than, say, a control. There was something, so the costing that I was doing a couple years ago was, or a year ago was, it looks like we come in at being able to sell water doing this, the water that we conserve, at half the cost of conservation and efficiency measures, and those are usually the cheapest water you could get, right? And about a tenth the cost of the desalinization, without having to do the upfront giant capital-intensive costs. And then there was this wonderful thing that happened last summer. How many of you read about the shade balls down in LA? A lot of you, right? Lots of press. And these guys used these 4-inch, is this why I brought the persimmons? If anybody liked the persimmon bread, I brought 5 persimmons to give away. These people used 4-inch black plastic balls, reinforced with carbon black so they wouldn't degrade in the sun, and floated them on this LA reservoir. And the idea was, if you think about it, what they did, they had these videos, right? I guess you guys probably saw them, of rolling these things into the reservoir. Cost millions of dollars. And what they basically did was they were reassembling a pool cover, right? But a pool cover's job not only is to reduce evaporation, you also want it to warm your pool, and it does an admirable job of that. And it does it by reducing your evaporative loss, by allowing you not to have any evaporation at all. What we've done, so we filed patents way back when, I'm an inventor, on our ICE 911 things, and we would never charge anyone to save the Arctic. I mean, no, but it covers cooling applications too. And what's nice about this, although it's really, the patent examiner's having a hard time with this, by allowing evaporation to occur, because we're cooling, it's reducing evaporative loss because we're cooler. And this is the trick here. And what's nice about that compared to what's here with these shade balls, A, it's a whole lot less expensive. We're about a 70th of the cost. And B, we're not killing fish. Last summer also in the Pacific Northwest, there was Washington State had one sort of salmon, 1.5 million salmon died because they were getting boiled to death in their lakes and rivers. If we did this, and Gulf of Maine's having similar problems, I'm hearing with, it's just horrible. If we put our kind of materials there instead, we too would reduce evaporative loss, but we do it by keeping things cooler. So it should be a whole lot easier on wildlife. So this is our trick. And this is what we hope eventually our patents are allowed. And so what we found is that we've got just, short-term tests in a parking lot, very small scale. Remember, when you're operating small scale, you're never going to show the full extent of how good you can be because it's all edge effects, right? It's like, well, yeah, but it was really warmer than it should have been because we were leaking heat in around the edges of the pool. So this should be understating how good we could be. But we were cutting water loss by 26% over the course of our slightly less than a week test. And that was comparable to what they were doing with the shade balls in this big old reservoir. And we kept our peak temperatures a lot lower. And there's a question.
The shade balls were actually not put in to reduce evaporative losses. They were put in to stop a reaction that was a chemical reaction.
That was true a few years ago, but I don't think that was the implementation this summer. This summer it was about stopping the evaporation.
I read that it was about stopping a UV driven reaction. So that's why it was black.
That was, so I read about that one a couple years ago, and I think what they were doing this year was trying just to conserve water. But you're right to point out that other use. The only thing I could read this year about it was it lasts longer in the sun. But okay.
I just read this article just this fall, actually.
Okay.
So I guess I assume it was talking about the most recent version, but it could not be.
Yeah, these guys appeared a couple years ago. I'm thinking it might be the same company. And right, there was some, I suspect, a chlorination that they were doing on I think it was a different reservoir, and they were noticing it was turning into a carcinogen, a photo-initiated reaction, yeah. And so they wanted to just block the light from that. So, but, and then when you dive deeper into it, you find, oh, the world works like you think. The other things those had been used for were called bird balls at airports to keep birds from landing on these ponds, which, okay, inimical to wildlife, okay, and was being used in waste treatment plants to keep things from freezing. So they were intentionally trying to keep things from freezing so that they could keep doing their waste treatment. Said, oh, okay, it keeps it warmer. So I was feeling kind of gratified that things worked that way. But this summer was the first time I saw them putting them in for what the headlines I was reading were about was reducing evaporation. Because they're desperate, right, for drinking water. But you're right to point out that use too.
So a question about putting the reflective materials on snow or ice rather than sort of open water. If you then get to relax the constraint of needing it to float, then do you get any benefit in terms of the cost of your materials for a given reflectivity?
That's a smart question to ask. We've tried some materials that aren't very floatable, sheet type things. Yeah, I've tried, one of my favorites to try was called Teslin. And what I liked about it was extremely porous because I still wanted to be able to permit evaporative loss. And that worked really well. I had, like at least a couple feet of snow preserved underneath this compared to outside up on Serene Lake where I worked in the Sierra years ago. The problem with it is sheets, that was the worst winter of my life. Charging out there to reposition the sheets, there's no way to anchor them. It's just so hard. And that means eventually it's so costly. So that was my non-floating thing that I tried. The advantage that we've seen with this stuff, our best behaving stuff that's bright and floats, is that every time it starts melting a little, this starts floating to the top. So it keeps doing you some good. Whereas these that are darker and don't float quite as much start drilling their way in. So, but I think you're asking a really good question. You know, is there, if you're on snow and ice, and if you don't care if it floats, in fact, maybe you'd rather it didn't, maybe you'd rather it sank when you're done, so you just say, okay, more sand on the, because basically the floating glass is sand. More sand on the bottom of the sea, that's not bad. Maybe there is something we could relax there, but give us ideas. You know, if you think of it, let me know, because we will try it. As you can see, you know, this is part of the philosophy here too. You can come up with these great ideas at your desk and you can say, this is going to be it. But as I think just about everybody in here who's an engineer is going to, you got to convince me by testing it, right? So if you come up with a good idea, we would be thrilled to test it. And we'll keep on doing it. So there was that. And then, you're right, we were keeping our temperatures lower by like 3 degrees C, more than 3 degrees C every afternoon in these small-scale tests. And this is profound. This is consistent with what I'd found years ago in tiny plastic tanks on our deck. So we're finding that we're saving water. We're finding we think we'll be able to avoid the kind of fish die-off that's been seen. And, you know, if your area now is getting torrential rains and you don't have a drought anymore, the idea is that you could pick this up and move it to the next drought-stricken area. It's not like a reservoir where it's just going to stay there forever. This is something that you could redeploy. One of the questions that was asked was, what can you do today? And there's a number, and we're officially a minute over time, I'm sorry, but we're coming right into, yeah, that's like it, right? And so there's a few useful things for you to find out. You know, what I've been trying to teach you here and all your guest lectures is how could you start something if you come up with an idea that you care about. But some of you are asking, what can I do short of that? You know, for today, while I'm thinking of that great thing that's going to save the planet, what can I do? And Oro Eco is Ian Monroe, so he's over in Paris, his particular startup. And I've gone ahead, hey, thank you for being here. Take some food on the way out. It's been fun. That's one way that you can get to learning what your climate impacts are, Oro Eco. It's very difficult, I found so far, to drill into where can I say, you know, is eating red meat worse than flying in an airplane? I haven't found the magic button there yet, although it looks like it could be. There's pages and pages of very useful ideas there, and you can get your own sort of blueprint of how are you doing. There's TerraPass, which does give you this kind. There's staying connected. There's donating if you see things you care about. Certainly there's changing your career. And there's starting something new. And what will you carefully do? And if you've got time to hang around and talk over Hershey Kisses and persimmon bread, please do. And somebody take these. And it's been such a pleasure knowing you guys. Thank you so much. It's really